Okay, hello. Hello, ROS developers. How are you doing here? First day of the ROSCON, and we are starting with the workshops. And I want to congratulate you because you have selected the best workshop of the ROSCON, of course. So congratulations, yes. Very good. And then we'd like to do some announcements before we start with the meet. Yeah, you are here. You came here for the meet. So first announcement. What I want you to do in this workshop is to learn a lot. So I want you that you leave this workshop by thinking, oh, I learned a lot. So that was useful. Not just hearing this guy explaining some things, but I got something back to me when I come home. So that's my main interest here. And for that, I would like you to practice with me. So you have to do the things that I'm going to do on the screen. So all of you have to open your laptop. If you don't have it, open already, connect to the Wi-Fi, and start to practice. So what are we going to do to practice is you are going to use your computer, and it doesn't matter which type of computer do you have. As long as you have a browser like Chrome or Firefox there, you are set up and connected to the Wi-Fi, of course. Then also I want you to ask questions. So don't worry, this is not a conference for trying to show how much do I know, or I don't want to show that I don't understand this. I want you to tell me if you don't understand, if you are lost. Okay, we are a lot of people here, so it's going to be a lot of work, but I don't mind to do it, okay? So if you get lost, if you don't understand something, just raise your hand, and then we'll try to figure out between all of us the solution to the question. Then finally, I have to tell you that we are going to do a 30 minutes pause at 3:15. So we are going to pause at that time, at that moment, for having a break with coffee and so on. So then that means that we have a lot of work to do in the rest of the time that we have, these 3 hours, actually 2 hours and a half, and the time that I am eating now, announcing all that stuff. Then let's go to the point. So what we are going to learn here in this workshop, what we are going to learn is how can we apply the OpenAI baselines, the OpenAI algorithms for reinforcement learning into ROS robots. Because as you probably know, the OpenAI baselines are state-of-the-art in reinforcement learning. And the problem is that the guys of OpenAI, I don't understand why, but they don't like ROS and the ecosystem there. So yeah, that's my impression of those guys. And they apply their algorithms into the Mujoko simulator without having ROS in the middle. So what that means is for us ROS developers, that's a lot more difficult to apply, yes? So what we have done is we have created, at the construct we have created a package that is called OpenAI ROS, that what it tries to do is to interface those baselines with ROS. So you don't have to care about the integration of the baselines in your ROS robot, as less as possible, I mean. So you can use off the shelf the baselines, the reinforcement learning algorithms that the guys of OpenAI, they have created. Okay, so that's the point of this workshop. How can I use the OpenAI reinforcement learning algorithms that are called the baselines into my ROS robot? Okay, for that, we are going to use a package that is called OpenAI ROS. Here we are going to learn how to use it and how to adapt to our own robots. Okay, so I hope that the goal of this session is clear. Where are we trying to go? We are trying to reach. And then for the class of today, what we are going to use is a tool that at the construct we have built that is called the ROS Development Studio. And why? Because that allows us to anybody here, independently of their computer or whatever you have here, is to practice all of us at the same time. So I have prepared a set of documents, a set of simulations, a set of code for this session, and I'm going to share this with all of you just right now. How I'm going to share this is by putting a link on the screen, and this link, once you type this link on your computer, is going to make you grab all these code documentation simulations. We, with the ROS Development Studio, what we create is what we call a ROSject. A ROSject is a ROS project that contains what I said, so documentation, code, simulation, data sets, everything is integrated. So when you copy this link, you automatically get all this information in the same conditions as I have. So all of us, we are going to be set up in the same situation. So we are going to work at the same, with the same code, and it's going to work in the same way for all of us. Okay, so let's go, let's start. So that's, here is my ROSject that I have here. Yeah, I can show you a little bit. So this is my area in the ROS Development Studio, and I have many ROSjects here I prepare. And this is the one for today. Then in order to, here you can see a screenshot of the documentation that we are going to follow. But what we are going to do is to share this ROSject here with you. For that, I click on share, and I get this link. So this is the link that you have on the, there on the screen. Sorry, on the board. It's for the people who comes late or just forget, but I'm going to put it here bigger so you can see better. Okay, so you have to copy this permanent link that is here. Type that into your browser, and by typing this, it's going to create a copy of the ROSject in your area of the ROS Development Studio. If you don't have an account at the ROS Development Studio, just create a free account. You don't need to pay anything for that, it's free. So just go there, open it, and you have to reach a page that I'm going to show you there. So I'm giving a few seconds until everybody has copied. Then if you type this on your, I'm going to do it so you can see. So I'm copying the link. I'm copying. Let me put the normal size. So if I open a new tab and then I press here, okay, so it has created a copy for me because I have already logged in into the system. If you are not logged in, it's going to ask you, please log in or please create an account or whatever, just free account, and then it goes. Okay, so that's my copy, and I'm going to delete it because I don't want it to keep more copies there. Okay, so once you have that, let me know if you get lost, okay? So once you have that, just press open, and then open again. Red, that's a flag, follow the red peel. And then, so you are going to get this screen where the system is initializing. Okay, so it's going to take a little bit here to initialize, some minutes, so let me, yeah, that's the previous one that I have open, so let me close it. So that here it's opening, and yeah, we have to wait. So please do also yourself, open it, because you are going to need all the code. And then I'm sorry for this waiting time, but we can have it for knowing better each other, you know. So you can say hi to the guys on your side, and then yes, friendship. We are going to stay here for 3 days, so we better are friends, guys. Okay, yeah, so what is going to happen? Okay, so we are going to follow a series of 4 notebooks. I'm pretty sure that you already know about Jupyter Notebook, most of you. If not, don't worry, you are going to know right now. And we have created 4 notebooks for this session. And we are going to follow the instructions on those notebooks. You can use those things also for teaching at the school, for example, at the university. I mean, so you can prepare a project and share with your students where all the instructions are there. That's an example of usage. And the same way that we are doing here. So when you open it, when it finally opens, then the notebook starts automatically, the first one that you have created. And then we can move it. Okay, unfortunately, I have here, I don't know, I messed it up, but this is not the number 1. This is not the notebook number 1, it's the number 2. This is the number 2. I know because I did it, so. Then for whatever the reason, it opened the number 2, so no worries, no problem. Let's open the number 1 manually. So you, at any point in time, you can close this. This is an application that is floating here in your workspace. You can close it at any time, and then you are going to get it back by coming here to the tools, to the menu tools, and then select Jupyter Notebook. Let me put it here. Can you hear me correctly? No. No. Okay. Okay. So I will try it like this. Okay. Well, so here we have the Jupyter Notebook, and we have all the list of the notebooks that we are going to run today here. So let's select the number 1. If you are there at the same point as I am, select the number 1, and this opens on another tab of the no, I don't think so. Don't worry. Okay, so you have another tab, and then here, this is the number 1 of the notebooks. So let's go step by step. I already explained to you what is the goal that we are going to do, but first I would like to show you an example. So let's do an example, a simple example with a Turtlebot robot. Then the first thing that we are going to do is to launch a simulation of the Turtlebot with a wall. It has a wall, and then the robot, the Turtlebot, has to start training to learn how to avoid the wall. Very simple task. So let's do the first thing. Let's launch the simulation. For that, we need to open a shell, a terminal, with these instructions. So here you have full instructions, and then launch the command for launching the simulation. Okay, let's go back here. I come to Tools, and then Execute Shell. Here is our terminal, and I'm going to launch the command. That is this one here, so I'm going to copy paste directly. It's very basic. It's ROS launch, Turtlebot gazebo, main launch. I'm a little bit lazy, so I like copy paste a lot. So now the simulation is starting, and in order to see the result, we need to open the gazebo window, which is here in Tools also. Probably you have seen before. So here, let me open the gazebo window. And here we have the simulation. Probably in your case, it will not open so fast. Let me know if you get lost on the steps, okay? So this is basics. And then we need to have the basics done and set up, because then afterwards we are going to move faster. We are going to speed up. Okay, so let me know. Then we have the simulation, the robot, so far so good. Okay, great. Let's continue with the notebook. What does it say? So now let's launch the training. Everything is set up already here for that example. But then afterwards, we are going to build another one all together. So how do we start? We need another shell and launch this command. My Turtlebot 2 training, start training, .launch. So let me copy. You must appreciate my skills with one single hand and doing copy paste and moving between things. So I think that's worth, yeah. Okay. If you get this CPU RAM, don't worry. It's because we are taking a lot of CPU, but you can just dismiss, and that's okay. So it's going to be a lot of CPU, but everything works, just a little bit slower. Then go to Tools and Shell, another terminal here. And I'm going to launch this training. So this is a very basic training. And the Tartabot is using a Q-learn algorithm. So very, very simple reinforcement learning algorithm. It's very difficult that it's going to learn to avoid that in that time. And also so you can see here the red errors, but actually they are not errors. We just didn't have time to change it because we wanted to see the message in red from the others, and we put an error message from ROS, you know. But don't worry, those are not errors. They are just showing some information. And here what we see is the training. So the different episodes that the robot is training. Here in the simulation, you can see how the robot is trying to avoid. So it's different episodes, different actions. The reinforcement learning is training, is trying to move the robot this way, this other way. And when it crashes, then it starts again. So those are the same, this is the same episode yet. Now a new episode of training has started. The robot is brought back to the initial position, and then you have another episode. So basically, this is a reinforcement learning training in a simulation. So probably you already know that. Then just in case that you don't, you now know how it looks. Okay? So this is for the Tartabot. That's cool. That's very cool. Then another thing that we can do is to plot the reward. Because we are using this OpenAI ROS package that you have here, the link. So you can go to this link and get more information, download it in your computer, and here you have some examples about how to do it. But I think that the tutorial that we are going to do today is a lot better than the one that is on the wiki of ROS, because we have prepared better than that. So I was saying, for the plot of the reward. So if you are using the OpenAI ROS, then the system is automatically plotting the reward at any what's the name? Episode? No, episode. For every episode, then it's plotting on a topic that is called OpenAI reward. So if you go to Tools and the shell, you are going to ROS topic list. You are going to see a topic that is here that is called OpenAI reward. And this is the one that is automatically plotting the reward for each episode. You don't have to configure anything in your code. So you are going to get this for free, let's say. So what does it mean? That we can plot it. And, so I close. So I'm not so skilled, you see. I close the window. So you can plot it, for example, with RQT multiplot. So this is a way, an example. So if you copy this command for launching RQT multiplot with a very specific configuration file that I have included into the ROSject. So let me copy this, launch it, and then I will show you. So on this new terminal, I'm going to launch the RQT multiplot with the config file. This is the command that is written here, okay? So you can see. So now we should be able to see something like this. I mean, when I took this picture was in a different moment. So what we are going to see is the number of episodes and then the reward for that episode. And how do we do that? Well, this is running here. So the application is running, and this has popped up a new window. It's an RQT window of the system. So how can we see on this web application a new window that is a RQT window? For that, we have here Tools, an option that is called Graphical Tools. And this is kind of a desktop where you can put any window of any application there. Okay, if you get this message, just press Load. And then here we have. Then here there is it should show here the whole content. If you don't get that, just press the icon to make it full screen, and then it's going to show. It should, yeah, here it is, okay. And once you have this in RQT plot, you have to press the play in order to start getting the data from the different topics. So now it has obtained the first point from the previous episode, and now it's repeating for a new episode. So we are going to see here how the reward is being plotted, just in case that you need it for your reinforcement learning task. Okay, let's see. Let me see another one. So here we have 2 points, the first 2 points, 1 and 2. Yeah, I think that we better put it like this. You can detach this from the main screen by clicking on this icon. So for example, if you have 2 monitors, then you can have this window in another monitor. So what I'm going to do is press this icon. So this window is going to appear as a new tab here. That is. So now it's not here, and we have a little bit cleaner. Okay, so now we have 3 rewards for episode 12, 13, 11. That's it. Well, that's an example. I just wanted to state the basis. Okay, so you know what we are going to do. What we are going to learn here is how can I do all this, but for my robot. So it's very nice that you provide this for the Turtlebot, but I'm not interested on that. I'm interested on my robot, you know. So that's what you are going to learn here. So please be patient. Please don't push so much, guys. Okay, so any question up to now? Any doubt? Is anybody following this? Is doing anybody here? Anybody? 1, 2, 3, 4, 5, 6. Okay.
Mine is not working.
Yours is not working?
No, it's not.
Okay, why not?
No, it said it was deprecated, something in Python. No, I closed it. And now it's just connecting to the terminal.
Okay, so it should work in the same way. It should work. No, but I mean, it's everybody has the same setup.
Yeah, but it didn't work.
Okay, so you are using the.
Yeah, I tried my Turtlebot and it crashed every time, but now it just stuck in.
Okay, so also has problems.
I ran the first command to run the simulator, but nothing. The simulator didn't come up. Now I'm trying.
Okay, yeah, the simulator doesn't come up. The simulation doesn't come up. You have to go here to Tools and open the window.
Yeah.
Is it?
Hello.
Okay.
Now it's just connected to the terminal. But it's not. I can just follow.
Okay. So we'll have a look afterwards in the coffee break. And what about you? Better?
Yeah, I started, so I was
Okay. Okay, so let me see if I'm missing something here still. Oh, yeah, well, this is the basic explanation about how this system works. And basically, what we are doing is to creating an environment of training by using the OpenAI Gym code. And we call this one the Turtlebot 2 maze. And then what we do is we create an instance of the QLearn algorithm. And then finally, we do the typical loop of reinforcement learning, that is for a loop for the number of episodes and a loop for the number of steps on each episode. And then we apply this action, select an action based on the current knowledge of the policy. Then we take the action and the environment that we have created here. This environment is the one that defines the task to be solved. So we take the action, and then by taking this action, we get a reward and a new observation. And then we use this for learning on the QLearning based on the state, that is the observation, and the action taken and the reward taken. And what is the next state? This is, this is the typical reinforcement learning loop made in this code. Okay, so this is the code this is actual code that we are executing. How can we check this code? If you come here to the ROS, then you go to Tools, and we are going to open the IDE. Just open the IDE here. And then this code is included into the Catkin workspace here. We have a set of different already set workspaces. This is like this is the hard disk of the system on the cloud that you are using. And this is the content of the project. Everything that you have been seeing here was already included in one of those workspaces for you, already. So if you go to the Catkin workspace, then source, you can see up here a package that is called my Turtlebot 2 training. That is the one that we have launched. And then you go to source, and here we have the QLearn implementation and the script that we have launched, start training. If you open it, then here we have just what I explained to you in this place. The environment, the QLearn instance created, the loop, and so on. Let me briefly show you this. So here we have the environment, then logs and whatever variables. We are going to see that in a minute. And then here we have the QLearn instance created, and then here we have the two loops. First one for episodes and second for steps. And then the action, here we select the action, here we apply the action and get the reward and observation. And at some point in time here, let me see here where it is. Here, okay. So here is where we learn based on the results. And then we repeat and so on, and the rest of things are just logs and other stuff that is for housekeeping. But basically, that's it. So we are going to learn how to do this for us, for our robot now. Okay, so let's go. I think that we have everything covered here. No, okay, yeah. So how are we able to do this? Is by using the OpenAI ROS package. And the OpenAI ROS package is what allows us to interface the baselines of OpenAI with the ROS robot and the gazebo environment. And in order to do that, what we have done is to divide the system, the whole problem, into different parts. First, we have the simulation here. And then we have a class that we call the gazebo environment. It's a connector to the simulation from an OpenAI environment. You don't have to touch that. This is already done by the OpenAI ROS package, and it's the same for any work that you are going to do if you use gazebo and ROS. So that is already done. This, you should change this in case that you would like to use a different simulator, that you could. Then, next thing that we have to implement is the robot environment. This is the class that gets the data for a specific robot. This is a specific of the robot. So for each robot that you would like to use in your reinforcement learning, you need to create a robot environment. The OpenAI ROS package already provides for several robots, for Turtlebot 2, Turtlebot 3, and so on, one manipulator, drone, so you can check afterwards. They're already if you download it. Then this is the class that we are going to implement here today for our example. Then you have to create another class that is called the task environment. This is the one that defines what you actually want the robot to learn. So how to compute the reward, how to get the observations, and how to apply the actions. And then finally, we have the learning algorithm. We mentioned the training script, sorry, because it has two parts. One is the learning algorithm, that we are going to use the ones already made by OpenAI, but then you have kind of plug this into the whole system, and that's by using this start training algorithm script in Python. This is the one that I just shown you here. This is the one. So we are going to learn now how to build all of them for one example. And yes, so I think this is just an overview, okay? So you are going to see now how to do it by yourself. Then for that, let's go to the second notebook. You can click here on the second notebook, and then the second one is going to open here. By the way, you can see all the notebooks here in the notebook workspace. So if you go here, you can see all the notebooks that are here, the files. You can download all this code, you can download to your local machine and then execute in your local machine. afterwards if you want. No problem at all. The only thing is that you will have to have a complete environment set up in your system, and the libraries, that requirements, and so on. So you have to meet that. But apart from that, everything is just plain ROS packages that you can download, or files. So here you have the notebooks that are plain Jupyter notebooks. Here you have all of them. Here the images of the notebooks. So you can create your own. You can modify all of those by clicking here and then modify whatever you want. You see here. So that's a way you can create new files here, so everything that you need. So not necessary now. So let me close this one here. Let me also stop the training. So we don't need this one anymore. It's the graphical RQT multiplot. We don't need the training anymore, neither. And we don't need either here the simulation, so I'm going to stop it also. There it goes. Okay, so now let's go and let's learn how to apply this to our own robot. Then, as an example, we have selected this interesting robot that is called the Kubli. You know that one. Do you know, Roger? No? Okay. So it's quite nice because it's a cube robot made by the ETH Zurich, and then it has some wheels on inside, and the behavior is that you spin the wheels and then you stop it, and because of the inertia, then the robot moves. Okay, so the real robot has 3 wheels on 3 different axes. In the case of here today, we have one single axis, and we want the robot to learn how to move forward in the y-axis. So we wanted to learn just to move forward, not jumping from one side to the other or going over it. No, just move forward. Very simple task. Okay, so then before starting, we have to define the reinforcement learning problem. And first, we need to define what is the robot to use. That's a Kubli robot. Can you see there? Let me put it a little bit bigger so you can see better at the back. Then the task to learn, that we want to learn it forward, to move forward along the y-axis. Then which learning algorithm we are going to use? The OpenAI Baseline DeepQ. This one is the one that we want to use, for example. Then the actions available. Which actions does have this robot? We define as the engineers, we decide. In this case, we have put those. We don't know if those are the best because, I mean, we haven't studied this problem. Maybe there are better solutions to that, but it's just an example. So we have 5 actions labeled from 0 to 4. Then 0 is move the speed wheel forward at one given speed. Move the speed wheel backwards. Stop the speed wheel. This is usually, if you stop, is when you create this moment of inertia that makes the robot jump in one direction or another. Then make a small increment or a small decrement of the current speed. Those are the actions. Okay, and then what we are going to observe? What is the observation? Remember here on the reinforcement learning, so we need to get this state. What is the information that we are going to get in the observation? So the current speed, the linear speed of the whole robot. So this current speed means of the wheel that is inside. Yeah? This is the linear speed at which the robot is moving on this axis. Then the distance traveled, and then the raw pitch and yaw of the robot. Finally, we need to define the reward. What is the reward? Well, the distance traveled in the distance traveled on the y-axis, and then we have put here the axis speed. So if you move faster, then you will get more reward. And if you move away from the y-axis, then you get some penalty. I don't know if this is the best way of training this robot for that task, okay? So I don't, because as you probably know, in any reinforcement learning, it has a lot of work on. okay, that direction and trying. So we don't have that time for at the construct. We're a small startup, and then but this is an example. So maybe, actually you have homework at the end of the class here, so you are going to have some homework, and then maybe you can use this for improving the result. Okay, so if we have that, what do we have to do in order to, what do we need to do in order to have this system training for that robot? First, we need a Kavli simulation. This is necessary. You need the simulation. Then we need to create the robot environment to connect the learning algorithm to the simulation. This is this block here. The robot environment, remember. This is the one that connects to ROS topics of the robot, gets the data, and provides to the OpenAI system. So that's the purpose of that block there. Then we need to create a task environment. That is the one that defines how we create the how we take the observations, how we apply the actions, and how do we compute the reward. And then finally, we need to create a training script that is the one that creates an instance of the algorithm, of the baseline of OpenAI, and then executes this loop that it's going through episodes and steps and doing everything. Okay, here it looks like everything is okay, it's done, we have it organized, but here we have a big issue in ROS. And the big issue is that OpenAI works on Python 3, but ROS works on Python 2.7. And that's a pain. So in order to merge those things, we need to create a Python 3 environment. So we have to create this environment and execute the algorithm from that environment being activated inside our ROS system. Okay, so you are going to learn how to do that. I mean, I don't think that we have time to, but you have all the information, it's there. Okay, so I have already created this for you. It's already created on that ROS jet. We only need to activate, but you have all the steps that I took in order to create. In case that you need more information, we can discuss later after the workshop. But that's a big issue. I mean, having that working, it's a lot of pain, of errors, source of errors. Okay, so let's start. First thing, we need the Kavli simulation. Hopefully also prepared for you by the amazing team of the construct. And the only thing that we need to do is to launch it here. Remember that you can find this simulation here. If you go to the IDE, we have another workspace here that is called simulation workspace. And here in the source, we have the moving cube description that is a ROS package, a gazebo with gazebo information. Okay, so you can check it later. Now we are only interested on launching it. So we copy this launch file, launch command, and go to the system. And in one of the terminals that was already open, or open a new one, for example, in this one that I launched the Turtlebot, just paste the command. And I have the window already open here, but in case that you close it by any reason, so don't worry, go again to Tools, Gazebo. And then the simulation should show up. Here it is, the simulation. And the red dot is on the other side. It's, let me see, okay. That, with one single hand, that's, okay, let me see, I don't know. No? Yeah. Oh, hey, okay, you got it. So, yeah, the red dot is nice to see in which direction is looking the robot, so that's why. But anyway, we have the simulation there. So now this step is covered. Remember the steps. We are going to follow all those steps. First one, Kavli simulation. So done it. You got it there. In your case, the simulation of your robot. Yeah, you had to create it. Sorry for that. So If you buy a robot that already provides this, so that's better. So that's why I recommend that you buy robots of companies that support ROS and provide the simulation already there. It's easier for all of us. Then let's go. We have the simulation. Next one is to create the robot environment. The robot environment, I'm repeating, okay, because I know all this information is new for you. So I want you to get inside your brain. This is the robot environment. This is the class that connects to the topics of the robot. So this is the class that we are going to build now. And it connects to the topics of the robot and then provides this information to the OpenAI environment, to all the system of OpenAI. And how can we do that? How can we provide this? And how can we connect to the topics? So that's the thing that we are going to learn here. Basically, we have several here. If you go to the ROSDS, you can see on the Catkin workspace here. Let me close this one. Here on the Catkin workspace, on source, you have the OpenAI here installed for you. Okay, so this is installed for you here for this project. You can download on your own computer if you want to do these kind of exercises on your local machine. So here, if you go to source.
Quick question.
Sure.
I think a lot of us are having our thing timed out. Is there a way to avoid that?
Yeah, no. Yeah, that's a problem. Yeah, that's a problem of the connection. That's a problem of it's because the system is detecting that your computer is getting disconnected too long from, so every time that you do from your browser to the machine on the cloud, there is a lot of delay between one ping and the other one. And then it disconnects because whatever you think that you are doing, you are actually not doing anything. So that's why, and then you should click there. That's a problem of the connection and probably of the Wi-Fi of the system. But I'm sorry, I cannot provide anything better. For my presentation, I requested specifically a cable, so I'm cable connected. That is why it's because of the presentation, because otherwise it will be very poor presentation, you see. I'm sorry about that then. Then, as I was saying, here in OpenAI package, you have here some robot environments already created for you. For the Carpo, for the Fetch robot, Hopper, Usarion robot, drones, etc. But what we are going to do now is to create our own here. So how do we do that? Well, first, let's create a package that is going to contain this code. And here we have the instructions about how to create. This is basic ROS, so all of you already know. Is to go to the Catkin workspace, create package, and then use the same command so we can be sure that there are no typo problems, and then afterwards doesn't compile or doesn't find the package or things like that. So it's just create a package that depends on ROSPy and OpenAI ROS. Then we go inside, create a scripts directory, and inside there we are going to create our Python file. This is the Python file that is going to contain our robot environment. Remember, the robot environment is the one that allows us to connect OpenAI to the topics of the robot, topics or services or whatever, the controllers of the robot also. So that's why we need this class. So I'm going to go to copy everything and launch it in one of the terminals that I have open already. So yes, let me close here a little bit. So here I have my new package. It's called my moving cube. I have just created. Any problems? No? Guys of the back, any problems? Are you following? Go. Hello? Hello? Everything okay? Problems? Say. No? Okay, okay. I just want to help you, so please feel free to ask questions. Raise your hand, something. Okay, so we have here the moving cube package, and then inside the script, we have this file that is empty. I'm going to open it. It's the my cube single disk environment. So I open, double click, and then it opens. Let me close this one because we don't need it anymore. So here is where we are going to, bless you, we are going to put all the code for the robot environment. And for that, we provide a template. So here is the template for you. We only need to copy and paste, but in case that you afterwards, you miss that, inside the OpenAI package, templates directory, you have a template for robot environments and another one for training environments. So you can use those later for your own robots. Great, so let's copy all that. Let me select everything, then copy, and go to the file and paste. So that is the template, the basic things of the robot environment. Then for this, let's go step by step, okay? And then let's see what we need to create for our own robot on this template. First of all, we need to initialize the robot environment class. Of course, now the class that we have here is just a class, my robot environment, but let's make it look something meaningful for our robot. And let's go here, and what we have is this class. It's called my cube single disk environment. So let's create that. And this one inherits from the gazebo robot gazebo environment. Remember that this is the one class that we have here. And this class is already provided by the OpenAI ROS, so you don't have to worry. This class is the one that takes care of stopping properly the controllers when you need to do the reset of the robot. That's also a painful thing. Gazebo, if you don't do it like Gazebo likes, you know, with love, so you need to put a lot of love in stopping the controllers, restarting them, then everything crashes. So that's the class that takes care of it. So you don't have to. Then, yeah, so that's the class of the robot. And then, let me see how I can explain you this better, but yeah, because here we have a lot of the work already done, and then I wanted to, okay, yeah, I see. Okay, so then what we are going to do is to create the class and the init of the class. This is what we are going to do in this step. Here we have this class, and then the init, and then something else in there. So let's create first this init class, and the init function, the constructor of the class, and then let's go step by step. It's very, very simple. So you can copy all the content of this cell. Actually, you can copy here from class to the bottom. Here it is, copy. Then go here and then select everything in your template until you put here, until you just remove all the thing that is in the inside. Damn it. Let me see. Okay, so I need to copy again. I need to copy again. Control C, then come here, select the whole class, and down here, and then paste. Okay, now it makes more sense. Yeah, so basically what we have done is to name this class with a name. Then we are providing a list of the controllers that need to be reset. So this is important for the system because your robot will have controllers of different types, and Gazebo is very sensitive to stopping, what I mentioned to you. So you have to include there the controllers that you want the system to restart, and then, well, robot namespace, whatever, and then this is an initialization of the model class. So in this case, it's of the Gazebo environment. So we are initializing the Gazebo connector in this point. And we provide for that the list of controllers that need to be initialized. And we want to reset the controllers from a start. In this case, we indicate that yes, but maybe in your situation, you don't need the controllers to be reset. Maybe it depends on your situation of the problem that you want to solve. And yeah, that basically it is. Then here, what we have here is that we have to unpause the simulation and then actually execute ourselves the reset controllers command. And this is going to take into account the list of controllers that we have passed to the Gazebo environment. And finally, we have here the subscribers to the topics that we want to use for our robot. So in this case, we want to use the joint states in order to know the state of the wheels, what is the position of the wheels, then the odometry in order to know the position in the wall of the robot, and then we need a publisher for sending commands of velocity to the joint, to the spinning wheel. Then finally, we have to do a check that all the systems are ready. This means the topics are publishing, the services are running, the subscribers, they are available. This is very, very important because when you do repetition of one step, one episode after another, you sometimes Gazebo does something strange, the simulation does something strange, so you have to be sure that at any point in time, all your systems are ready, are correct. So this is in the initialization phase, okay? So here still we haven't done, when the code is executed, it's just initializing the machine learning problem. Sorry?
The function just returns true. You say it's important, but check all systems ready, it just returns true.
Sorry? Say it again.
Never mind.
No, please say.
I just, right below you have the function, and it just returns true. It's not.
Oh, yeah. We are going to do it now. So remember that this is the template, and we are filling the template step by step. Okay? So, Look at this at the template, but thank you for your question. It's very well spotted. So maybe there will be errors in here. I don't know. So don't mind if you spot it. We can correct them. Yeah. So here in the template. So it has to be done here yet, and then also here, what I have explained is already on the template. Almost of the things. The only thing is that you need to specify here your list of controllers for your case, your robot namespace. If you want, for this example, the controls to be reset after every episode, and then that's the same for any robot. The only thing that you have to change is this name here. That is the name that you have indicated for your robot class, for your robot environment. That's it. Basically, that's what I have done in this initialization here. That's it. And here, what I mentioned to you, it's explained here. Okay, how to fill all that, and related to the controllers. So you can know, if you don't know about this robot, which controllers it has. So these are the commands that you have to issue in order to get the list of controllers of your robot. So for example, of the Kubli, if we issue this command, we are going to get this answer. And that's why here we got the names of the controllers that we have to reset. Those are the ones that we have put here, in in the controllers list. In case that you have some others, just keep adding. Then we need to define also the callbacks for the subscribers. Remember that we have subscribed to two topics, the one of the joint states and the odometry. So we need to add this code there. So let's go, let's add it. Let's copy the code here. And let's go to this here, let me see. So I'm going to put after the gazebo and pause. So the two methods of this class, they are very specific for this class. They are required for this specific class. So in your case, you will have to identify those two for your robot. These are the callbacks. Remember, the callbacks that we have defined here on the subscribers. Okay, so far so good. How are we going on time? Okay, 15 minutes more. I think we can finish this. Then, next thing is about the question of, what's your name? Tor. Yeah. Okay, so the question of Tor about checking all the systems ready. So this is the thing that we are going to do now. And this is very important, really, because otherwise, if you don't do this step, that's something that happened to us at the beginning. Then you think that your system is running and is training and for hours in there, and then you go and something has stopped. Something in the simulation, something crashed in your, I don't know, in your control loop of your simulation, something crashed, and then it's not working anymore. So you are losing all this time. So in case that you detect those situations, the system is going to tell you, and then you can take action afterwards. For example, save the current policy and then stop everything and restart loading the save policy and training from that point, for example. Question?
So this sounds like something you probably don't get right the first time. How do you debug this? How do you detect this other than just letting your simulation run for hours? What are some sanity checks that you can do as a developer?
Yeah, so how do you detect is with those functions here. So here, for example, we are going to check if the joint state topics is there and is able to publish. So if we can receive information from there, then whatever you would need for your robot to be running, then you need to include into this function. So this one, so we have this function that is called check all systems ready. Okay, so there you have to put everything that you need to check for your robot. You're specific. I cannot tell you for your robot. In this case, we need to check that the sensors are ready. So we have this function here, and that the publisher connection is, so we can connect to the publishers. And that's what we have implemented here. But I don't know if I have answered the question here.
If you just check if the values are not zero, because often if you have invalid published in example range, it's never 0, 0, 0. But it is if it's not initialized.
Sanity checks make sure it's
Yeah, you just check that it's not 0.
Ah, okay.
Zero,
Okay, in this case, when you try to wait for the message for that topic, if it is not available, it's going to generate an exception. And that's what we are capturing here.
But often you get a message, but it's empty, and it's just zeros.
Ah, okay.
If you just check that it's not everything 0.
But then in that case, the publisher will be working, but it's the information that is inside the publisher that is not working.
In my experience, most of the time, they are publishing, but
okay.
something it's 0.
Yeah. Like, for example, it's not connected to the laser.
Yeah.
And then the publisher is working, but the information is publishing is rubbish, for example. That's a very good point. Then you should put it here also. That is specific time. And then what is going to happen in reality is that you are not going to put that because you don't think about it. Then you, oh, I'm safe. Then you put it there for training for 2 days, and then at the end it doesn't work. But then you have to go realize, and then you add here. Okay? So basically that's the procedure. Okay, so let's go with all the check systems ready. not going more into detail, but basically we are checking that, all those things. So first, that all the sensors are ready, and then in the sensors we have divided into two parts, the joint states and the odometry. And then we check that the publisher's connections is still there. So here is the check, the publisher's connection. So you can have a look at the code later. It's not it's just basic ROS. It's basic stuff of ROS. So, I mean, it doesn't say much for this workshop. That's a little bit tricky. Oh, yeah, Control A, yes. So let's add this into the template that we have here on the robot. And yeah, so that's definition. Check all systems ready. What I'm going to do is to select everything and replace. Okay. Check all systems ready. Yeah, where is? Oh, here. Okay. Yeah. Great. So that's for checking the systems. And then these are two methods that the task environment is going to need in order to move the joints. And then, yeah, so basically it's only one, move the joints. And this move the joint is going to wait until the joint has got the proper speed. Because we want the robot to set a certain speed, and then we want to wait. This is very specific for this application, okay? The only thing that you need to know is that, let me see. Yeah, so the only thing that we need to take into account is that move joint. This is the one that it's important. That's the one that is going to be called. That's the one for setting a raw speed. We are going to see that later on the task environment, how this task environment is calling this function here. And that also depends on your robot. So that's why on here, on the template, okay, so I think that I didn't delete this one, so I'm going to remove. That's from the previous thing, okay? Yeah, I did something wrong in the copy paste. I don't know what did it, but here on the template, you have this part that is empty. That is where you have to put the task environment methods. So the functions that the task environment is going to need in order to execute the actions, for example. In this case, we have this one, to move the joints. That's it. So this is the function that we are going to create. The move the joints is calling this one also, that is necessary for that specific task. So let's copy and paste all those two functions to that place in the code. Copy and paste. Okay. Okay, so basically that's the robot environment. This is the only things that you need. Let's review very quickly. First, you need to create a class with a constructor that defines the list of controllers, the robot space, and then initialize the gazebo connection to the simulation. Then we reset everything, the controllers, everything, and then we connect to the topics and publishers that we need for our system. Finally, on the init, we pause the simulation. So we have to control, this is important to have the pausing system correct, because otherwise there could be a lot of delays in the system. Then you need to prevent the robot from keeping doing something just because there is a delay in the system. When the robot, the next command should arrive, but there is a lot of load in your computer, so you are pausing and unpausing all the time, pausing and unpausing all the time the simulation in order to produce a sensation to the robot that is a continuous flow of the algorithm, and then you do not depend on the load of your computer. Okay, so yeah, that's it. We check the systems, that everything is running, and then we provide some functions that the task environment may need. So at this point in time, maybe for your robot, you don't know exactly which functions do you need. So you will have to come later. In this example, we already know, because it's easy, because I mean, I have prepared for you that, but in the real scenario, you will come later there. Just follow the instructions of the template. So here in the template, just follow, we have put some comments, and where you have to include the different functions for the different connections. One with the robot gazebo environment, another one with the task environment. And those two are these ones. So this robot environment has to connect here, and this one has to receive calls from the task environment. So basically here, let me check the time. I think that we can stop here, or maybe any question that could be. So some minutes we have until the break. It's 7 minutes until the break. Any question? Yes, question.
So am I supposed to face toward the MyCube signal this environment?
Wait a second. Let's use the mic, so it's easier for me to hear.
Hi, yeah. I just want to ask. Right?
Yeah,
so
sure.
The class MyCube signal this environment, right?
Yeah.
Am I supposed to place it over the MyRobot environment and then replace everything in that class?
Let me see if I have understood correctly.
Yeah, I think so.
Yeah. So you mean this one? Well, here.
So yeah, we start off with this, right?
Yes.
We're supposed to just replace this whole entire top portion of it up to all the def check all systems, is it?
Yes, correct. Exactly. Yes, exactly. Here is where you, basically here we are doing only, here in this part, we are doing only the initialization of the class. So it's the constructor only of the class. And then for your case, you have to change here the name of the robot environment that you would like to have. And then then you have to provide mandatory the controllers list. If there are none, then there are none, 0. Then the robot namespace, in case that you have a namespace for the controllers. You see here, there is a controller's name. Well, here it doesn't show, but in the controllers config, it shows this robot namespace. And then initialize the class of the gazebo connection. So basically, that's all. Then, oh no, sorry. Then you have to include these subscriptions to the publishers and the subscribers that you are going to need to get information from or to send information to. Yeah, I don't know. I think that I'm not answering your question. Maybe you have some information additional for that?
No, I mean, yeah, we're replacing the class in the template.
Yeah.
Class that's in.
Yes, yes. In this exercise, we just change it directly because it's already done. So here in the moving cube, check. This is for the moving cube already. Already done. This is for the moving cube, already done. And what we have done here is just take the template that is here and then substitute all this part, that is the definition and the constructor, by the content here. That's it. Yeah. Yeah. Okay. Okay. So.
I don't know if it kind of comes in right, but we also need the inputs too, right? Like not just the class, we need the inputs as well.
Which inputs?
The inputs that are at the top of this.
Oh, okay. Okay. Yeah. Yeah, but in this, okay, yes. This should be, exactly. So these imports, they are, yeah, I forgot about that. Those imports, maybe you have some that are specific for your robot. In this case, it's the odometry that is here and the joint state. That is correct. And I haven't included there. So yeah, so I have to include all that. Yeah. So what I'm going to do is, just for the sake of having everything working correctly, I'm going to select all this. and then go back there and replace all the beginning here up to the constructor here, to the end of the constructor. Yeah. Okay, wait. It was selected the template. Sorry. Here, template out. Here it is. Okay. Yeah. So yeah, you are right. I forgot to indicate that you have to include these imports that you may need for your system. Yeah. Those are specific of your robot also. And the float, yeah, float, this one is used somewhere here on the publisher. Yeah, here. Okay. Yeah, any other question? Yes, on the side?
Yes, I just want to confirm, will this project be able to use after the workshop?
Will you be able to?
Use the project?
Yeah, sure. This is for you, for forever.
And is it possible to use it without going through the cloud? So
Yes, sure.
Online, offline on the
Yeah, you can use online there, and then for free, you have up to 30 hours of usage per month. So every month you have 30 hours for free for using there. Then every month, then afterwards it resets, and that's all. And in case that I'm tired of the cloud, whatever, then you can download it. Here there is an icon here to download it to your local machine, and then you will download everything. If you don't want to download everything, just the notebook, just the simulation, come here to the IDE, and then select the directory, right-click, download, and you get that. But if you don't want, for example, I'm using a Mac. I'm not installing ROS anymore. I'm doing all my work on ROS using this system. It's super easy, because afterwards I can use your computer to access to my account and program, and then I travel to somewhere and do that. And also I can share my work with everyone. I just share with all of you there, and you can get the same results as I have, except for Thor, that he's having some problem there. Yeah. Well, I'm eager to finish to go and see what's happening there. So actually, we are doing for all of you. If you don't have more questions, your questions are my priority. But yeah, go ahead.
Yeah, have you ever implemented this in a real robot?
Okay.
Have you ever done it? It seems like this is a little too immature to actually use in an example in an industrial application.
Okay. Yes, it's very early stage.
Yeah.
It's at a very early stage. So what we have done some things, okay, about that. So let me show you. Let me go to my list of projects, and I have here one for domain randomization. Let me search, because I have many. Okay, that one. Let me share that also with you, so you can get that. That's an amazing job that we did. That was horrible. So basically, we have replicate the results of OpenAI on this robot that learns to grab the spam from the table with a lot of distractors, and then it transfers to the real robot. So it trains on the simulation, and then it transfers there. So we did the replication. Everything is there. How to train your system, how to create the database, how to label, everything is there. So let me share with you. You have a lot of work. So you want to follow and everything is explained in there. So let me share this with you. Okay, that's a very large. It's a very large, but if you are interested, just take a picture or something. Take this one of there. And so we replicated the same results of the paper in the simulation, and you can replicate too by following these steps there. And then, but the thing is that the trained model, we need to transfer into a real robot. And then we didn't have a fetch robot, so we went into a collaboration with PAL Robotics. It's a company that is from Spain and then sells humanoid robots and others. And we use his robot called Tiago. Tiago robot is similar to Fetch. So we have to create the same procedure again for Tiago, but it's okay. And then we transfer to that Tiago robot. But the results have not been conclusive. So we achieved that to do the transfer and to execute in the real robot. But for me, it was like too much prepare. You know, it's too much, it was too much easy, the setup. So I want to repeat that process again. And once we have this repeated, we are going to publish everything that that you can, so you can reproduce. Let me tell you that in case that you want to execute on the real robot here, so you can connect the system with, here we have an option where you connect to the real robot. And then whatever you execute here, you can decide the master in which you want to connect to execute either on the simulation or either on the real robot. Okay, that's a paying feature, okay? So I don't want to talk to that because I'm not for selling here. So just ask me, then I will tell you. But for the rest, so did you copy this, this link? It contains so much information like the one that I am sharing here with you today. It's a lot of work. That is a very, very large project, very large. Okay, so guys, let's do a stop so we can have coffee because I ran out of coffee and I need to refill and come back in at 45. And we are going to continue with the last part and then execute on the simulation. Almost there. Thank you. Thank you.